Let's graph the function negative 2x cubed plus 36x squared minus 120x plus 2 on the interval 2 through 10. We're going to find the intervals where it's increasing, decreasing, any local extrema, whether those be maximum or minimums, and what's going on with concavity. So the first derivative tells me what's going on with increasing and decreasing. So I'm going to take the derivative of f of x to get f prime of x. The derivative of negative 2x cubed, the 3 drops down, negative 6x squared. The derivative of 36x squared, the 2 drops down, 72x. The derivative of negative 120x, negative 120. I'm wondering when this equals 0 because I'm trying to figure out what are all the critical values. I'm also wondering where this thing is undefined. So let's set to 0 to find those critical values. My potential maximums and minimums. So negative 6x squared plus 72x minus 120. I'm noticing these all have a 6 in common. I actually want to divide everything by negative 6 to clean it up a bit more. So negative 6 over negative 6, that makes that x squared. Great. 72 divided by negative 6 is negative 12. And finally, this last thing becomes a 20 there. I'm looking for two numbers that multiply to give me 20, but add to give me negative 12. Those numbers are going to be 2 and 10. Negative 2 times negative 10 is negative 20. Negative 2 plus negative 10 gives me negative 12. Setting each of these pieces equal to 0 and solving tells me something is interesting happening at 2 and something is interesting happening at 10. I like to make a number line with these values, 2 and 10, for the first derivative, so I can have an idea of what's going on with increasing and decreasing. Because I know at 2, the derivative is 0, and at 10, the derivative is also 0. If I were to plug in to this equation, starting equation here, the value of 0, doing a test point here, I would have 0 squared, 0, plus 72 times 0, so I have 0 plus 0, minus 120 gives me that this is a negative there. Negative 120, but honestly, I just care about the sign. So that tells me going into 2, it's decreasing. Let's see what's going on from 2 to 10. I need a test point. I'm going to try something like 5. Or even 3. Small's fine. If I plug 5 into my derivative function there, and I do the math, so negative 6 times 5 squared plus 72 times 5 minus 120, I get positive 90. So that tells me it is increasing from 2 to 10. Finally, long-term behavior here, this negative x squared, this is going to open downward, which tells me that this is going to get more and more negative as x gets really big. If you did a test point of f prime of a large number like 100, that's going to spit out a positive, a negative value. So it has sort of that derivative shape of negative 6x squared, where it is decreasing, increasing, decreasing. Doing a rough sketch of what we have so far here, this tells me going into 2, it's decreasing. After 2, from 2 to 10, it's increasing. And then from 10 on, it's decreasing. So 2 is actually going to be a local minimum. And 10 is going to be a local maximum. I already have an idea of what this graph is starting to look like with increasing and decreasing. Let's write out those intervals exactly. So it is increasing from 2 to 10, and it is decreasing from negative infinity to 2 and from 2 to infinity. I also know that I have from negative infinity to 2 and from 10 to infinity. I also know that I have local maximum at x equals 10 and a local minimum at x equals 2. So first derivative told me quite a bit. The second derivative will tell me what's going on with concavity. So we have f prime of x is equal to negative x squared plus 72 x minus 120. Taking the derivative of this, f double prime of x, will give me negative 12x plus 72. The 2 drops down, that x goes away. I want to know when this is equal to 0. So I'm going to set to 0 to find potential inflection points. So I have 0 equals negative 12x plus 72. I get the x over on that left side by adding it. I divide by 12. That gives me an x value of 6. So for the second derivative, something really interesting is happening at x equals 6. Let's do some test points. If I look at a value smaller than 6, say 0, and I plug that into your second derivative, you would have negative 12 times 0 plus 72. You would have 72, which is a positive number. If you were to plug in a number bigger than 6, say 10, you would have negative 12 times 10 plus the 72, and that would give you a value of negative 48. So it is a positive second derivative before 6, and it is a negative second derivative after 6. If your second derivative is positive, this tells you that it's concave up. If your second derivative is negative, this tells you it's concave down. So in particular, I have concave up from negative infinity to 6, and I have that it is concave down from 6 to infinity. This also tells me I have an inflection point at x equals 6. Let's take that and add that to our sketch. Two to 10. So far, I had that it was decreasing into 2, increasing out of 2, and decreasing after 10. concave up are pieces that look like a U going upward. Concave down are pieces that look like a U going downward. So going into the value of 6, this first piece is going to look like a U going up. I'm going to smooth that out a bit. And after 6, it's going to look like a U going downward. So my sketch of my graph looks like this. It goes down, up, and then down. If you plug in the specific values of 2 and 10, you can find those maximum and minimums. This particular question only wanted you to graph on that interval of 2 through 10, no problem. So it'd only be looking at that chunk right in the center. I'm going to pull up Desmos or GeoGebra and graph to compare. I want to see how close we were. Here's my graph in Desmos. Going into 2, it's decreasing. There's my min at 2. At 6, I have that inflection point. That looks great. I have my maximum at 10, and it's concave down from 6 to infinity. So by looking at the first derivative, we could tell where it's going up and down. By looking at the second derivative, we can figure out concave up and concave down. So I can get a pretty good idea of what's going on with the general shape of my graphs.